Hello everyone, this is Silavarsi, Assistant Professor, Department of EEE, Karpagam Academy of Higher Education. Hope you remember where we started our module. Our first module is about electricity basics, and we have discussed on the electric circuit, voltage, current, and also on the symbols that has been used in the electric circuit. And then we moved to the second module. In that we discussed on the Ohm's law and its definition, and also the concept behind the Ohm's law, and we told at constant temperature the voltage is directly proportional to the current and resistance. So in today's class we are going to discuss on the factors on which your resistance depends. So it depends on two main parameters. One is your resistance and the next one is your resistivity. Resistance is the measure of opposition of your electric current, whereas resistivity is the characteristic property which depends on the restriction of your current. So both of these parameters vary in your temperature. So simply we can say a resistance always depends on four main parameters. One is your temperature, and next one is your length, and third one is your resistivity, and fourth one is the area of cross section. When your temperature is hotter, more resistance will be produced. In case of your length, if it is more resistance will be produced. And this resistivity rho, it varies for different materials. And your area of cross section is thinner, it will lead to more resistance. So concluding all these four parameters, we can say that my resistance R will be equal to rho into L by A, which means my resistance is directly proportional to the length and it is inversely proportional to the area of cross section. So this is the formula for your resistivity. Simply I can say resistance directly depends on the length and inversely depends on your area of cross section, and rho is the resistivity, and that is different for different types of material. So it always depends on the temperature. So these are the four main factors on which my resistance depends. Now for example, remember this formula, R is equal to rho L by A. If suppose I am having a conductor, of length that is L and area of cross section is A with a resistance of R. And we are introducing a new material which has a conductor length of 2L, area of cross section is the parameter that we need to find out, and with the same resistance R, because the material remains same. So we have resistance R. So how will you find the area of cross section? As we know, our formula for resistance is R is equal to rho L by A. If you need to find the area of cross section, it will be replaced here, right? So you will get rho L by R. So this is your first solution. And then I am saying I am having a conductor, introducing a new conductor of length 2L. So my new length will be equal to 2L, and I need to find my new area of cross section, right? So my formula for area of cross section A2 will be equal to rho into L by R. I am replacing this new length by my formula. So rho into L2 can be replaced as 2L by R. So what happens? Here I am taking out my 2 outside. So this can be written as rho into L by R. Rho into L by R is nothing but, from our formula we can say that is A. So this can be replaced as 2 into A. So my new area will be equal to 2 into A. So I am saying if the new material of my conductor is doubled by its length, my area of cross section will be 2 into A. This is how we need to find the resistivity of a material. Moving on to the next problem. The second one is a material of length and area of cross section is 0.2 meter and 0.5 meter square. The resistance of the material is 3 ohms. I need to find the resistivity of the material. So, given is the length, and the length is 0.2 meter, and I am having the area of cross section, that is 0.5 meter square, and resistance of 3 ohms. So I need to find the value of resistivity. So we know that R will be equal to rho into L divided by A. A is the area of cross section, R is the resistivity, rho is the resistivity, L is the length. So what happens? R will be equal to 3 ohms, right? So 3 will be equal to rho into, for L we have 0.2 meter and for A we have 0.5 meter. So replacing this 3 into 0.5 will be equal to rho into 0.2. So again 3 into 0.5 divided by this 0.2 will give you the rho value. So solving this we get my rho will be equal to 7.5. The resistivity unit is ohm meter. So this is how we need to calculate the resistivity of the material. So on the whole, my resistance depends on 3 main parameters. One is my length, area and the resistivity. Also this resistivity and resistance varies with respect to temperature. That is what we need to remember in this concept. We will move on to the next problem. So here the same thing. The third problem is I need to compute the resistivity of the material. Provided I have an area of cross section of 25 centimeter square, length of the material will be 15 centimeter and the resistor is 2 ohms. So to find the resistivity, I know that R is equal to rho L by A. So what happens here? R is 2 ohms and the resistivity is the unknown one. I have a length of 15 centimeter. Converting this 15 centimeter, I will get 0.15 meter. Converting this 25 centimeter square into meter, I will get 0.25 meter square. So now I can apply it directly. Length of the material is 0.15 whereas the area is 0.25. So what happens here? 2 into 0.25 will be equal to rho into 0.15. And finally, to obtain the value of rho, what happens? 2 into 0.25 will be divided by 0.15. So my resistivity of the material is 3.33 ohm meter. So this is how we need to calculate the resistivity. So on the whole, I conclude that the factors on which a resistance depends is 4 main parameters. One is the temperature of the material, resistivity of the material, area of cross section of the material, and length of the material. So careful designing and consideration of this will provide a better solution. So thank you. We will meet in the next module.